Welcome back, Franken friends. Greg Smith, aka Dr. Frankentosh. Today we're going to do part 4 of our series on object-oriented programming in C, where we extract out the methods from each of our objects and create a set of methods that are a class that are shared among our objects, and then the object points to that class as a set of virtual functions. So let's get started on that right after this on Dr. Frankentosh. Okay, let's go to the magic whiteboard and take a look at the way we constructed the LED blink object or class. LED blink. So we layered these on top of each other. We had the name instance variable. Then we also had the delete method and the debug method. That was part of GObj. Next we had the Gpio class, and in there we had the pin and the direction, and we also had the reset method. Then under that we had Gpio output, and that had the set method. And then finally we had our LED blink, which added the delay, the last time, and the state. And we added the blink method. Now what you may notice is that we have 5 different methods here. And when we make a copy of the blink, we have multiple instances of this. All of these methods get copied into the next object. And these method pointers all have the same value, so it's pretty redundant. So we can extract these out into their own class and just put the delete and debug, reset, set, and blink methods into their own object. We'll call this the LED blink class. And rather than have these elements in here, we'll just have what are called instance variables, like this. And then we'll have a single pointer called the class pointer that points here. So now when we make a method call, we'll be saying this class, say blink. And because this syntax is a handful, we want our little macro to do our syntactic sugar. We're going to do this, going to blink, but internally it'll expand so that this becomes, that's what this little macro will expand to, and then that will allow us to have our blink method. And the other thing our syntactic sugar does for us is it sets the global variable that equal to this. That is another thing we're going to change. I got tripped up quite a bit in the last video talking about global this and local this, and what I've decided is I'm going to call that global variable that, so we'll be pointing this to that. Hopefully that'll make it a little easier to understand. So this picture is a little bit confusing. Let's see if we can't get a better picture of what we're aiming at. So what we're going to have is what's the instance object with all of our stateful information, things that will change between the individual objects. There will be a class pointer, and then at the top will be the name, then our and then the direction of the GPIO pin, the pin number, and then finally the LED elements, which are the delay, the last time, and of course the state of the LED. So these are all instance variables that describe the state of the object, and then that will point to our class object, which will have our methods in it, things like debug, delete, reset, set, and blink. So when we create another LED, like let's say this was the red LED, it's get a copy of that pointer to the class, and then the name, which would be equal to red. The direction, of course, is out. The pin would be 5, and then these other values for the delay, which was, I think we set to 250 milliseconds, the last time, which was now, and then the state, which was off. Now let's create a second object, and this would be our green LED. The class points to the same table of virtual functions, but the name is equal to green, and the direction, again, is out. Pin 6, the delay was 500 milliseconds, our last time was now, and then our state was off. Now when we go to call the blink method, we'll be doing red, and then the macro will do the syntactic sugar for us, which will go to class, which will then go to blink. And when that happens, the blink method will get the that variable, which would then be assigned to this, and then the blink method will get the instance object, this instance object here, right? And it will operate on this instance object. And then when we call green, it will also set that so that this will be set appropriately when we get there. It will call the exact same blink function. So green will then go to this virtual table of methods. It'll call blink, but this time it'll get this instance object, and it will delay 500 milliseconds instead of 250 milliseconds. And so now what we have is this virtual table of functions that's shared between like objects, and when we call that virtual function, it will get the instance variable associated with it. Now, the other trick is that this class is for LED. Blink will have a different virtual table for LEDPWM. It will also have methods debug and delete, etc., and blink, but this blink method will point to a LEDPW blink, whereas this blink pointed to LED blink. Okay, so these are two different virtual tables, and when we create that, let's say, yellow instance object, it'll have its own name, which will be yellow, and it'll have all the PWM options that are instance variables that are associated with PWM. And when we call the LEDPWM, because this class pointer points to this virtual table, one different from the LED blink, it'll not only get this yellow instance, but it'll call this different blink method, different from the LED blink method up here, and so it'll act like the PWM LED. So I know this is kind of complicated, but in a lot of ways it's better. You can see that the instance objects have only enough information in it to describe the state of the object, and then the blink class has all of the methods associated with that type of object. And so it is this virtual table of functions that creates how this object acts, whereas the instance variable declares its state, or how its state of being, what it is. So let's go ahead and take a look at the code and see how that looks. Okay, so let's take a look at the code. We have refactored our code, and if you remember, the ObjectH had some stuff in it that managed our macros and such that made our object-oriented programming paradigm work. And I've extracted that or refactored that into its own source modules, and I'm calling it General Object-Oriented Programming Environment, or GOOP. And so in GOOP.h, you can see that we have our standard includes, we have our new external variable for storing our calling value, which we call that, because calling it this was confusing with where we actually had this used elsewhere. And then we are now calling object class when we call methods, and I'll get into that in a minute. And then we'll also talk a little bit about calling superclasses. And of course, there's our now function, which is external to the entire project. So going back to goop.c, we just have the instance of that and also the actual function for now. If we look at object.h, so if you see this red screen, this is the original code that I released last time, and the black screen is the refactored code. So if you look at gobject.c, you can see here that we have our method calls, right? But now we're going to move these methods, the debug and delete, we're going to move them into the class object. So let's take a look at what the class object looks like. Okay, so in the new code, we have not only GObject members, but also GObject methods. And we've moved all of the methods, and you can see this when we look at gobject.h. We had our methods logged in with our members, and it created for a very fat hierarchy of objects, especially as we got deeper into the hierarchy tree. So what we want to do is take these members or these methods out, put them into their own class. And so we have the GObject class with a super pointer. We'll talk about that in a minute. And then whatever methods are associated with the object. And then down here, as before, we have our GObject members, but we also have a pointer to the class, which is this object. And so every time we call a method on an object, we go through the class pointer. And this is what gives us our virtual functions. So let's look at one layer deeper than that. Let's take a look at GPIO. So here's GPIO. It inherits from GObject, so we have to include GObject.h. Our GPIO members include only the pin and the direction. Now, if you remember from the original code, we also had a reset method, but we're going to relocate that reset method down to the class. So down here are the methods that are associated with this. We inherit the object methods, and we add on the reset method. So you can see that this is the same pattern that we used for members before, but now we're also doing it with classes. And we're taking all of those methods out of our instance object and putting into our class. So there are two different parts here. There's the class, which is a set of virtual functions that we will be calling on behalf of the instance object, and that's this bit down here. The other thing to notice is that everywhere we go in these interface files, these .h files, we're always going to see this. There's going to be a something something class with a super and all of its methods, and then a something something, which is just the instance, a pointer to its class, and all of its members. And above that, there's always going to be something something members with the parent or superclass members, followed by whatever we extend the instance object to include, followed by something something methods with the parent methods, followed by whatever extensions we add to this object. So this is the pattern that we're going to have. This is going to serve us for everything else. I'll quickly go through the other classes. Here's GPIO input.h, GPIO members because it's inheriting from GPIO. Down here is the class, and you can see GPIO input methods, which inherits from GPIO methods and adds the new get class. And this goes all the way down. It's turtles all the way down. So let's take a look now at the C code, because we did have to add a new function that supports the whole idea of filling in the blanks of our in each of our superclasses. So if we go back to GObject.c, we now have a new method called GObjectClassInit. And when you pass in a pointer to a class, it will set the super pointer to null because there's no super pointer or no superclass to GObject. Set the debug method and set the delete method, and then return this static class. Remember up here, we have this GObject class, and it has an underscore class on it. This is a concrete version of the class that actually allocates memory, and we're assigning the super, the debug, and the delete pointers, and then we're returning the current class. So that may be a little subtle, and I'll go into that in a minute. But inside of our GObject new, one of the things we have to do is we have to set the class pointer. So we call GObjectClassInit with our static class, which then fills in the blanks for the static class, and then it returns the static class and assigns it to class. So now the GObject class and the instance object is up to date. But let's see what happens when we do a child class. Let's take a look at GPIO.c. We call GObject new, because that's the parent class, to initialize all of the fields in the instance object. And then we set class equal to GPIO class init, passing in its static class. Then we take the class and we set its super pointer to the parent class pointer. But we're actually passing in our GPIO class. Okay, it's a little tricky. Down here, we pass in the address of our static GPIO class. That gets passed in here. It gets passed into GObject class init, which then fills in the blanks for both debug and delete. Okay, and then when it returns the GObject class, which makes it the superclass of GPIO. Okay, so we've very cleverly both initialized our GPIO class and set the superclass to the parent. And we'll see why that's important in a second. And then we also set the reset method, and we're on our way. So this, like I said, this goes all the way down. But where this starts to get interesting is when we look at LEDPWM.c. First, let's look at the header file. It inherits from Blink, and it adds these 4 instance variables. It also inherits from Blink the methods, and it adds the set duty cycle. And then down here, just as before, this is all template code now. It's boilerplate. But look at LEDPWM.c. Now, this again is boilerplate. We did exactly the same thing. We called the superclass new to initialize all of the instance values. We called the superclass init to initialize the class. And so here's where we call the superclass init, set the super. But this is different, right? This time we're overriding the LED blink method. So this here, we'll remind ourselves this is an override. So we're replacing the LED blink method with our own blink method. And I'm going to go back to the original code, and we'll take a look at this side by side. So if you look at this side by side, you can see that the original LED blink function compared to the PWM blink function are very similar. The first line is the same. We set this variable. We check our delay to see if we've expired our timer. We reset the last time to the current time. We then update the state. We invert it, in fact. And then over here, we set the LED state. But over here, we do a special check that we reset the delay based on whether the LED is on or off. Because if it's on, we may want it to be on for a very short period of time versus the long period of time that it's off because of our duty cycle. This is very similar code. So the trick that we can pull here is that we can actually skip these 3 lines of code and actually call the LED blink code instead and have it execute that for us. This is really handy because if we change the functionality or the implementation of LED blink, we inherit that change. We don't have to worry about copying the code. This is another way of being dry. Don't repeat yourself. So let's take a look back at the new implementation and see how LEDPWM.c looks. I dereference this. I call the superclass, and I call the superclass blink. Now, because this has already been set that has already been set, when we get to the LED blink function, which was over here, it's going to get the same instance variables. It's going to execute this code, check to see if it's timed out. If it has timed out, reset the timer, invert the state, and then set the LED. But then when it comes back, it's going to do the specific code just for PWM blink, which is to check on the delay, reset the delay based on the state, and it's then going to check that if the delay is up to date, if it's non-zero, it's going to go ahead and set the LED again. This is really handy, and the reason why this works is because we've gone to the trouble of creating this mechanism whereby we get the superclass and copy those superclass variables in, and then we set the super pointer to the superclass virtual function table, and we can call the super methods. Now, Personally, I find this syntax kind of clumsy. In some ways, it's more expletive than what I prefer. But if you look into GOOP.h, I've added what I call superclass call. And so if you use double underscore instead of single underscore, it's going to call the superclass method. And you can see here it goes object class to super. And then that's the way you get to the superclass. So that's it. That's all of the GOOP paradigm. I do want to add one more thing, because if you ever get to the place where you want to extend a class, right, you have a lot of boilerplate code to recopy. I mean, you've got to do these if-defs, you've got to include the superclass, you've got to set up your members and your methods. You're going to copy one class into the new class, and then you're going to edit it. And that can be a lot of work. So rather than do that, what I did was I created some templates. And I have this template called XYZZY. That's just a random set of letters. It's actually historical. You might want to Google it. But you go to XYZZY .h, and it has these if and defs in the word super for the superclass. XYZZY is the name of the new class. So let's say, for instance, that I wanted to create a big button, right, that inherits from X button. So what I might do is take XYZZY.c, rename XYZZY copy.c to bigbutton.c, and rename XYZZY copy.h to bigbutton.h. Okay, so now we can go into bigbutton.h and using our find and replace, and I always set the upper and lowercase flag on. So we're going to replace all of XYZZY with our new class name, big button, and we're going to replace capital super with X button, which is the superclass. Okay. So let's see what we've done here. So our if and defs are set correctly. Our superclass is being included. So our big button members, our instance variables, include from the X button members, and we've got 2 sample members that we can replace with actual implementation details. Our big button methods, which inherit from X button methods, and then 2 sample methods for big button. And then this boilerplate code, which has the button class and the big button instance down here, the superclass pointing to X button, and then finally the big button methods and the big button members. Let's take a look at bigbutton.c. We have to do the same thing, replace the super with X button and replace the X, Y, ZZ, Y with big button. Okay, and so here's our sample method 1 and sample method 2, our big button static class, our initialization for big button init, and then here our big button class init, and then also our placeholders for any new methods that we had, and then our initialization function, which creates a new object, calls xButtonNew to initialize the instance variables from the superclass, and then also the initialization of our own class and our superclass pointer. So this took like 5-10 seconds, and we have a completely new class extended from the parent. And that covers it. That's pretty much it. So this concludes our series on object-oriented programming in C using the GOOP paradigm. I hope you enjoyed it. Please, as usual, don't subscribe to my channel. Please don't click down here or up there. Don't like this video. Your time is precious. Please spend it wisely. And thank you so much for spending part of it with me. And I hope to see you next time on Dr. Frankentosh.